Hello, in this video we're going to solve a basic trigonometric equation. And again, by basic, that's where a and b are coefficients of 1, c and k are coefficients of 0. So you're solving for sine, cosine, or tangent of an angle equal to a number. Alright, so specifically what we're going to solve for is sine of an angle. Where is that equal to? Negative 0.67. And then here are the steps I use to solve the basic trigonometric equation. I go through them more extensively in other videos, and I also have graphs so you can see what you're solving for, but this is more straightforward, just solve it. And then for part B, 3B, the other solution, I use these formulas, or I offer them to students. I actually do them just visually. I'll show you both, or you can use these little formulas. Alright, so let's go back and go ahead and solve for this. So here, first step, I really do want to find out what it is I'm really solving for. So I think you have to be careful about this and really ask yourself what you're solving for, because the underlying trig ratio tells you a lot of information, so you can't skip this. So for what angle in, and then you got to figure out, well, remember, where are you allowed to look for the solutions? So here, pi over 2 and negative pi over 2, right? We had to restrict the original sine function, or the sine function, to be able to work with the inverse. So here is where I'm allowed to look for the solutions, or for theta. And since I know I have a negative, right, and the underlying thing for sine is y over r, I know I'm going to be in this quadrant 4. All right. But the way the theoretical restrictions are, it's going to be a negative rotation into quadrant 4. So for what angle in this interval is the y-coordinate equal to negative 0.67. And again, I say y-coordinate, but remember, sine is y over r, which you could say y over 1 if you want to use the unit circle, or just y, right? That's why I read it this way. All right, so then I want to take the inverse sine of both sides. And I'll get that the angle is the inverse sine of negative 0.67. And I then put this in my calculator, and I'm going to get that the angle is negative, 0.73421 radians. I work in radian mode, unless specifically asked by the book or whatever. So here is our calculator solution. Right. So I figured out what it is I'm looking for. I've taken the inverse trig function of both sides. Used my calculator to find my solution, first solution, and then I need to find the other solution. And again, you can either use this, right, in which case you get pi minus theta, or I just do it visually. Okay. So again, what I'm looking for is, if I look at it visually, I know I'm going to be in quadrant 4, but basically the calculator gave me negative 0.73421, so let me go ahead and kind of draw that out. So I don't even go 1 radian in the negative direction, so I'm probably somewhere like, I'm just going to guess here. So let's say that's negative 0.73421 radians. When I drop a perpendicular to the x-axis here, I have an x and y coordinate associated with this. The y coordinate is here, negative 0.67. So that's what that's telling me here. Now, I need to ask, where else on the unit circle, right? Where else on the unit circle is it that I can find an angle whose y-coordinate is negative 0.67? Because remember, the calculator was restricted to look in here, and it gave me this. Right? But I want to know where else is the y-coordinate negative. So if I reflect this triangle here into the third quadrant, what I would see is this is what I would get, right? And I drop to the x-axis, right? And again, this y-coordinate is negative 0.67. Right? So essentially, this reference triangle is the same as this. Right? They're exactly the same. So but how do I identify this location on the circle? So again, what I do is I say, well, even though this is a negative rotation, the actual reference angle is positive. All reference angles are positive, right, and acute. So really, if I want to look at it as, well, what's the rotation starting at 0 to go all the way around, right, and then end up here, it's basically go pi plus that reference angle. So visually what I do is I say theta is pi plus, and I make that positive 0.73421, because I can see it. I can see that that's the rotation starting at 0, go all the way around here to pi, and then this little bit is the same as this one, and I just add it. So if I do that, I'm going to get theta equals 3.87580. Okay? Now, if you use the formula instead, which I would forget after a while, but it's pi minus theta. The difference here is that since theta is already negative, right, that's what the calculator gave you, you're doing pi minus a negative theta, and it'll make it positive, right? So if you do that, so if you did it this way, you could say theta equals pi, let's see, this for sine, let me just actually say here, the other solution. So I'm just showing you how to get to this same answer, but using the formula pi minus theta, but that's going to be pi minus, and then you'd have the theta, it's just negative 0.73421, and so you'd have equals 3.87580. Right. So either way, whether you usually do it visually or you use the formula, right? This is formula, you get to the same answer. So finally, you're at part 3C, and you're saying, well, what are my generators? And again, my generator is just my terminology, right? Well, it's all of these angles, right? Plus 2 pi, minus 2 pi, all the coterminant angles for that. So you're going to have theta equals negative 0.73421 plus 2k pi. And again, some books might already go ahead and put k equal 1, so you're finding the first coterminal angle and it's just pretty. That's fine. And then also theta equals 3.87580 plus 2k pi. Right? So those are your two generators, and they should capture pretty much everything. Right? And like I said, the only comment I have here, some books will go ahead and add 2 pi to this one right here, and make it a pretty angle. That's up to you, but it just means that k is 1 is all it is. All right, thanks so much for listening.